For this video, I'll be going through pure physics, practical electricity tutorial. Question 1. Figure 1.1 shows a 3-pin plug of a 3 kilowatts water heater. So this is actually the power, it's in kilowatts. What are the safety features of the 3-pin plug? We actually have the earth pin, which is connected, which has the earth wire. And the earth wire is actually connected from the ground itself to the metal casing. Okay, so this is in case any electrical fault and the metal casing, if it becomes live, then the current will flow through earth wire, which is actually a low resistance wire, into the ground. So anyone who touches the metal casing which is live will not get an electric shock, right? Because the current will prefer to flow through the earth wire, right? So it also has a fuse. Okay, what's the purpose of the fuse? So again, in the event that there's an electrical fault, okay, and this time the metal casing doesn't become live, but the electrical fault causes the current to exceed the fuse rating. Okay, so the fuse rating for this fuse is 13 ampere. We also have 1, 3, 5, 7, 9, 13 ampere fuse. Okay, so usually O level they'll ask you to choose which one is the most appropriate fuse. And for the fuse itself, right, it needs to be higher than the working current. Okay, the fuse rating needs to be higher than the rating current. The fuse rating needs to be higher than the working current, so that in the event of an electrical fault, the current which exceeds the fuse rating will melt the fuse. And when the fuse melts, it's actually a thin piece of wire, and so it will create an open circuit. So the current can no longer flow through into the appliances, so that the appliances is protected. Okay, the fuse must be always connected to the live wire, okay, so as to disconnect the appliances from the dangerous high voltage. So the live is actually at 240 volts. Okay, earth is actually 0 volts because it is connected to the ground. Neutral is the 0 volts. Okay, and current flows from high potential to low potential. So they want us to indicate where's the live, neutral, and earth. So basically, you look for the fuse. The pin that is connected to the fuse, it must be live, and you need to memorize the color of the live, which is brown in color. Now the earth will always be the top plug. Okay, so it is yellow and green in color, and then neutral will be blue. Okay, so they actually have this cable grip, so the wires are all inside this outer insulation, which is the cable. So we have the cable grip so that it can hold it in place. So this is the live wire, 240 volts. The top one is the earth wire, and the bottom one on the left is actually the neutral wire. So this is the fuse. What is meant by live wire is a wire that connects the high potential, in Singapore is 240 volts, of a power supply to the electrical appliances. What is meant by neutral wire is a wire at 0 potential. Okay, it provides a return path from the electrical appliances to the power supply to complete the circuit. What is earth wire? It is a low resistance wire that connects the metal casing of the electrical appliances to earth. So whenever there is metal casing, it must be using a 3-pin plug, okay, so that it can accommodate the presence of an earth wire. Now, what is the purpose of the fuse in the plug? They protect the electrical appliances from excessive current. So this is the purpose. And how does it protect it? So when the current exceeds the fuse rating of 13 ampere, the fuse will melt, important, and the circuit will be open circuit, so the current stops flowing, and then it will disconnect the appliances from the dangerous high voltage. So this is a very common O-level question. They ask, why is it that the fuse is connected to that particular wire, which in this case you have identified it to be the live wire. So this is what you can actually memorize. Fuse should always be connected to the live wire, so that when the fuse melts during an electrical fault, okay, so the fuse will not just melt by itself. There must be an electrical fault whereby the current exceeds the fuse rating. Okay, so sometimes there are electrical faults and then it results in the current exceeding fuse rating, so the fuse will then melt, and therefore the electrical appliances which is now having an electrical fault will be isolated from the high voltage supply. So if it's isolated from the high voltage supply, when I take these electrical appliances for repair, there won't be any danger to me because it is now isolated. It is not in direct contact to the high voltage supply. Okay, so this question can also be used to explain why the circuit breaker, okay, which is another safety feature, and the switch are all connected to live. Okay, so the live wire is 240 volts, very high potential, very dangerous. So therefore fuse, circuit breaker and switch, they are all connected to live so that they can disconnect the appliances when it's necessary from the high voltage. Now explain why earthing is essential. Now if there's an electrical fault, results in live wire touching the metal casing, which means that the metal casing becomes live. Okay, a large current will flow to the ground through the earth because the earth wire has very low resistance. So if a person who happens to touch the appliances at the same time, it will prevent the person touching the metal casing from getting an electric shock because the current will flow through the low resistance earth wire instead. So now if a technician wants to measure the voltage of the power supply, between which wire should a voltmeter be connected, live and neutral. So this will be 240 in Singapore and 0 volts for the neutral wire in Singapore. Okay, question 2. Figure 2.1 shows a 240 volts 20 watts lamp. So this is in terms of the symbols V and P, and also a 110 volts V 30 watts P lamp connected in series to 110 volts main supply. Okay, so if they are connected in series, their voltage will be the sum, right? The voltage across them will be the sum of the voltage that's being supplied. But if you look at this, the lamp's power rating states that it can only provide a power of a power of 20 watts if it's given a 240 volts of potential difference across it, which will not happen for A, right? Similarly, even though the power rating for this lamp is 30 watts, right, and it must have 110 volts of potential difference applied across it, okay, but because it is now connected in series to lamp A, so it will not be getting 110 volts. Okay, so the question will guide us because they ask us to calculate the resistance of each lamp. Now you have learned 3 formulas: P equals to IV, P equals to I square R, and P equals to V square over R. Okay, how do we get these 2 formulas? We can mix up, so that means you need to memorize the base formula, which is P equals IV, and if you mix it up with V equals to IR, you'll be getting 2 different forms of this formula. So if you want, you can just memorize it. Okay, make sure that it's P equals to I square multiplied by R, or P equals to V square divided by R. But if you don't want to memorize, you just memorize this base formula and then you mix it up with V equals to IR. So they want us to calculate the resistance of each lamp. Therefore, because they have, let's use lamp B, the resistance of lamp B will not change because resistance is based on R equals to rho L over A formula. So even though the voltage across it changes, even though the current flowing through it changes, right, we assume that the temperature remains constant, so there won't be any change to the resistance because resistance is based on the resistivity multiplied by length over area. And since none of this is changing, so the resistance of this lamp B, we can take it that is constant, provided that physical conditions remain the same. That means the P and the that means for these two values, which is P and V, right, I can actually select my P equals to V squared over R to calculate the resistance. So I'll get 2880 ohm and 403 ohms. So if they are connected in series, that means the total resistance will be 2880 plus 403. Okay, so we'll be using this here because they want us to calculate the current drawn from the main supply. Meaning, if I have like example 110 volts here, then I have this 2880 ohm in series to my 403 ohm. Okay, and my effective resistance is actually 110 volts. I can make it into one single resistance, which is 3283 ohm. Okay, so with this, I have my V, I have my R, I can then find the current. So not difficult. It is 0.0335 ampere. Okay, 0.0335 ampere. So this is the current that will be flowing through lamp A and lamp B. Okay, lamp A and lamp B. Now, suggest a suitable fuse rating. So the fuse rating, which is over here, and emphasize the point here that the fuse, okay, has a symbol that looks like a resistor but a line passing through it. So this one represents the thin wire. Okay, so this is the symbol of a fuse. It must be connected to live. Similarly, the switch also connected to live. Okay, so that if there's anything, we can disconnect the appliances from the dangerous high voltage, right? So suggest a suitable fuse rating. So 0.0335. So some of you may say 0.50 ampere, which is okay also. So something that's higher, but not too high. So maybe rule of thumb is 15 to 20%. So then there'll be a range of values, right? So what I see in O-level question is that they usually give you 3 or 4 values to choose from. Okay. So calculate the power developed across each lamp. So we can use P equals to I square R because we know the resistance and we also know the current. So of course you can use P equals to IV, but because you know your current from part B, you need to then determine your V, right? And V we can determine from V equals to IR. Okay, so actually if I substitute my V equals to IR, I also will get this formula P equals to I square multiplied by R. So sometimes if you can memorize, it is good to know these 3 formulas by heart. So you'll get the power across each lamp 3.23 watts and 0.452. So if you are to compare, you see for lamp A, by right it should be giving out 20 watts. But only under the condition that it is given 240 volts, which it isn't given that. Okay, and lamp B is actually supposed to give off 30 watts. Okay, but it didn't manage to even get to 1 watts, right? It's only 0.452 watts because it wasn't given its required 110 volts. Okay, so this is a common question that they ask in O-level. Right, what happens to the power or the current or the voltage if it is not given the voltage as specified in the power rating? Okay, now which lamp is brighter? Lamp A, it depends on the power dissipated. So lamp A gives off 3.23 watts. Okay, and complete the following table when the circuit is working normally. Okay, this is also a common question, right? What is the potential of neutral? It is 0. Earth is also 0. For the current, it must be the same in live and neutral, right? Because that is the path that the current takes. For normal condition, there shouldn't be any current through the earth wire. Okay, for part G, you just look at the answer. The advantages is that both lamps will be brighter than when they are in series. Okay, that's true because they are each given their required potential difference. And if one lamp fails, the other can still operate. Now, what's this one disadvantage? There will be higher total power consumption if I connect them in parallel. But actually, I don't really agree with this disadvantage. I mean, it's true, but I mean, we have our household lights all connected in parallel is because that we can switch them off by themselves and we can get them to have the required power rating. Okay, but I mean with that then we will have to pay more for the electricity bill, so it is not really a disadvantage. Okay, but anyway, okay, question 3, 3.1 and 3.2 shows the electricity tariff charged by Singapore Powers. Okay, so you see that there is money involved. Whenever there's money involved, you must change your power from watts into kW. You must change the time from from seconds, example, okay, to hours. So the SI unit for power and time is watts and seconds respectively. Okay, but whenever you see them mentioning money, you need to change your watts to kilowatts, you need to change your seconds into hours, because that is what it means here, kilowatt hour. Okay, so I have an aircon, the watts, the power that it uses is 750, so maybe I can change it to 0.75 kW. For the clothes dryer will be 5 kW. For computer will be 0.2 kW, and fan will be 0.115 kW. Okay, so this is in SI, but this is what we need when we are calculating money. So they want us to calculate the amount of energy consumed by the computer after operating for 30 hours. So this is my T. Okay, amount of energy is E. Now energy equals to power times time. So since they want it in kWh, I need to convert my power to kW. So for the computer is 0.2. The time is already converted, so I will get 6 kWh. Calculate the amount of money that can be saved when a portable fan is used for 150 hours. So this is T instead of an aircon. Okay, so we also did the change in because they are talking about money, right? So we should be using this column here, whereby everything is in kW. Okay, so if you apply the formula E equals to PT, you'll get 17.25 kWh. Then aircon will be 112.5 kWh, with both of them being used for 150 hours. Okay, so you can see the amount, the difference in the energy. So you will take 112.5 minus 17.25, we get 20.52. So we have 1955 cents or 19.55. Okay, so you can leave it either in both if they didn't specify the units. Now, explain why it's dangerous to handle electrical appliances with wet hands. So the resistance of the skin reduces when it is wet. Okay, try not to say that the water is a good conductor of electricity, right? It's not so true, but we can just say resistance of skin reduces when it is wet. So this will increase the current flowing through the body if there is a case whereby you suffer an electric shock. Okay, so if my hands are wet, my resistance decreases, the current increases, and this will increase the severity of the electric shock that will experience by the body. Okay.